Alright, for assignment 2.5, there's really not a whole lot more that we need to cover. This is kind of more practice from what we did with the linear equation section. It's just more specifically just looking at the thinking as these linear equations as functions. So one thing that I need to tell you is that if you want to determine whether or not a function is linear, what do we mean by that? Well, if you think about the graph, that means we're going to have a straight line. But as far as the equation, we mean that you can write it in the form y equals mx plus b. Remember that from last time, our slope-intercept form. And really in this section, you're going to see it written as ax plus b. Okay, but this is just exactly the same thing. They're just using a different, and they're not going to write y, they're going to write f of x. Sorry about that. This is the exact same thing as saying y instead of f of x equals mx plus b. All we're doing is we're changing a little bit of the notation because we're specifically thinking about these things as functions. So y and f of x mean the same thing here. A still is going to be the slope, just like m. Okay, here, and a little bit of terminology. They're gonna call a the rate of change of our function, and that's the exact same thing as m that we call the slope. Slope, rate of change. That's the same thing when we're talking about a linear function. Okay, so when you see rate of change, that just means the same thing as the slope. Okay, so really what I want to do in this section is I just want us to kind of walk through some of the problems, and let's talk about them real quick. So here, the first several tell us to determine if the function is linear, and if it is, put it in ax plus b form. Okay, so the first one, all we have to do is switch the order, and it'll be in ax plus b form. Number two, let's look at it. We've got x times 4 minus x. So here's our function. If we have something like this, can we put that in ax plus b form? Well, the way we would try that is we would try to distribute. Here we get 4x minus x squared. Okay, and because of this, because we get this x squared term, this thing is going to be not linear. There's nothing we can do with that x squared term here, so this function's not linear. So if you end up with something that you can't fit into the ax plus b or the mx plus b form, that means that the function is not going to be linear. Okay? So just check that on these first few. Here it asks us to make a table of values and sketch the graph. You can make a table of values if you want to. You don't have to because it's in y equals mx plus b form. So here what I would do personally is I get my line tool, and then I see that my y-intercept is at -4, so I'm going to go down here to -4 and put my point. And then I see that my slope is +2, or 2 over 1, so I can go up 2 over 1, and that point will be on the graph. Okay, so there's my line. Then it asks what's the slope of the graph. Well, we said that was 2. Then we're done with that one. Okay. Same thing, similar there. So this one gives us a table of values, and it asks us to find the rate of change. That's our slope. So you use the formula from last time for m. This is our x coordinate, this is our y coordinate, and these are points on the graph. So you just find the slope there, and then it tells us to put it in the form ax plus b. Well, how do we get the y-intercept? Well, this tells us that x equals 0, or f of x, or y is 7. Okay, so it gives you the y-intercept there. Okay, here, find the rate of change, find the slope. Same thing. This one gives us the graph and says find the rate of change. Remember, that's like figuring out the slope. So you start at a point on the graph, count up and over until you get to the next point on the graph. So this one 1 up, 1 over. Slope would be 1. Okay, plug it in. Okay, so nothing too bad there. This last one looks a little intimidating, but just read it carefully. Okay, it says find a linear function v that models the volume of water in a pond at any time t. What gives us the rate of change is 10. And it says initially the pond contains 400 gallons of water, so that's our y-intercept. Okay? And instead of x, just be careful you're using t here. And then on this one, you just plug in for t. It's not too bad there. It's really very similar to what we did in the last section. If you have any questions on these, feel free to let me know.